Hello everybody, today I'll show you how you can create a road generator that will allow you to create this type of curved roads in your level with the unlimited number of meshes that you want to place on the road. Like for example, here I have this road item, the curbs alongside the road, the benches and this road barriers and light posts, and you can add as many objects as you want. Some of the objects you will add as a curved objects that they're controlled by the shape of the curve, and some other objects, like for example these benches, they don't need to be deformed, they are just placed alongside the road, so they are placed as a different type of objects. So this will create a very robust system that you can use to create different type of roads. For example, here I'm using a different mesh, and again I'm using the same road generator. Here I have a snowy road, again using the same generator. So by the meshes, the amount of meshes, the type of meshes, and the variables that you change here, you can create unlimited number of different type of roads with this generator. And not even only roads, you can create walls and barriers and fences. So the usage is unlimited, and this is a very useful tool for level generation, and I cannot recommend it enough. So guys, if you watched the previous two tutorials, which are how to use for loops in PCG and how the spline meshes work in PCG, they are very important to understand in order to know how to create this spline road. I'll show everything again in this video, but to understand the concepts properly, you can watch the previous two tutorials, and I'll add links into the description for them. And I think this is everything we needed as an intro. Let's start with beginning the generation of this PCG road system. Let's start with creating the blueprint to place the road system that we are going to make. So first, I'll start by creating two structures that will hold the data for the two type of objects that we can place, the ones that can be curved along the spline and the ones that are just placed along the spline based on the variables that we enter. So I already created the first one, which is this one, the struct for simple items, which will not be curved. It is composed by these variables. So first the start offset, then the interval, which we are going to place between the items, the mesh that we are going to place, the transform of the mesh, the randomization of the transform. Is it going to be kept vertical, like for example trees or white poles or something like this? He has mirror if it's on the both sides of the road that we are placing, and if the mirror object is reversed, this reverse mirror. So I'll create the second struct so you can see how this is done. Right click in your content browser, type struct, and it will find you this structure type. Click on this and it will create a new structure, call it as item curved. And now let's open this. And here, by clicking this add variable button, you can add multiple variables, and you just need to put the name and the type for each of the variables. So let's start first with the static mesh. We'll call this mesh. The type will be static mesh. Object reference. The next will be the mesh position. The type will be vector, then position offset. The type will be vector again. Next one will be has mirror. If our object will be placed on both sides, this will be a Boolean value. Then reverse mirror, if the mirror should be reversed. For example, the white poles, they both need to be placed pointing to the inside of the rod. That's why we have this reverse mirror boolean. Then for the static mesh, if you remember from the last tutorial about spline meshes, we need the forward axis and the up vector. So let's create one variable for the forward axis and one for the up vector. And the forward axis will be an integer and the up vector will be a vector type. Let's save this. Again, check if you have the other struct the same as mine. Start offset, interval, mesh, mesh transform, transform rotation, keep vertical, has mirror and reverse mirror. And the types are here. Let's continue now with creating the blueprint. Right click in your level, create a blueprint class. The type will be actor. Let's call it BP rolled PCG, for example. Let's right click again, create a PCG graph. Again, if you watched the previous tutorials, you will know how to load the PCG plugin, so I'll not show this. Let's call this PCG rolled PCG, for example, to be the same as the blueprint, but with the PCG in the beginning. So let's open the rolled PCG blueprint. Let's create a spline here that we'll use to draw the road, and let's create PCG component so we can connect our PCG graph to our blueprint. Drag the PCG graph here, compile and save. And now let's create the variables that we will enter into our blueprint to control the road generation. So add one variable, which we'll call placeable items, for example, and the type will be as item simple, the struct that we created, and right click here or here into the variable details panel, choose here the type array because we want to have multiple of these items. So let's create another variable here, curved items, and this will be of type as item curved. The other struct that we created, and again you should have an array type. So choose an array here and make sure you have this symbol with 9 squares. Let's make both these variables public by clicking the eye here or into the details panel, this instance editable checkbox. Let's compile and save this. And let's make the road, the curve for the road a little bit longer, because now it's just 1 meter and my meshes for the spline mesh are a little bit bigger. So in order not to have to edit this every time we place it, I'll just create a longer default value. So 1000 units into the location for the first point of my spline. Right now, if I place this blueprint into the level, I'll get this 10 meter spline and nothing else. Let's start working on the PCG graph in order to have some results. So let's open this PCG graph, let's save it. And now let's first start with one of the object types, for example the objects that are just placed along the spline. So for them, we will be creating a subgraph. Let's right click here, create a PCG graph again. Let's call this subgraph or PCG subgraph simple item. And if I drag it here and create a loop node, again, you should be first getting familiar with this concept by watching the for each loops in PCG graph tutorial that I have. I'll link both the previous tutorials that are needed to understand fully this concept for this road generation into the description, but I'll show how to do everything. Just to be more detailed about them, you can watch the previous tutorials. So I'm creating a loop subgraph here, and I'll right click here into the PCG graph and get actor property, and I'll get all the simple items from my blueprint by getting this placeable items variable. So here into my get actor property name will be placeable items. Now I'll convert this from attribute set to points. After I convert it, I'll do a attribute partition. This will split the data from one single set to multiple sets with just one point. And the partition attribute will be the index. And I'll input this here into our loop. So let's go into our simple item loop. This will be executed for each of our placeable items. Let's start first with getting the spline data from our level. We'll do a spline sampler. Let's for now create a distance of 100 units, and we'll just spawn the static mesh spawner. And to get this, the name of the static mesh, we'll use our input value here, because we are inputting all the variables contained into this struct into our PCG subgraph with this input point. So we'll make this from point to attribute set. This is converting first from unknown type to point. So let's make sure that our pin is actually set to point into the beginning. So let's select this input field and change the allowed type to a point. And now we don't need this extra note here. So if we change our input to point type, then we convert from point to attribute set. Then into this attribute set, we'll delete attributes, and we'll delete everything except the mesh attribute. And this mesh attribute will save into a name tree route. So drag and write at name tree route declaration node, and with F2 I'll rename this to mesh. So right now I have my mesh value into our mesh name tree route, and here before I'm doing the static mesh spawner, I'll add an attribute. So drag and write at attribute. I'll add the attribute output target to mesh, and the attribute will be my mesh name tree route. And here into the static mesh spawner, I will choose a PCG mesh selector by attribute, and the attribute will be mesh. Let's save this. Let's save the PCG graph for the road as well. And now if we go back to our level, if we select our blueprint, you can see that we have the two variable types, the placeable item and the curved items. We connected the subgraph for the placeable item, so let's create one entry for these placeable items and choose some mesh. Let's, for example, choose this road. Sorry, this is the placeable item, so I'll use the bench, for example, or something smaller because we are placing it each meter. So okay, right now I have this mesh for the white pole. and you can see the subgraph is working like a for loop. It's going through each of our points. Currently we have only one object, which is this lump, and placing it each 1 meter for our curve. Let's extend our curve by dragging out and moving it somewhere to be sure that we are placing our objects along the curved spline. Okay. Now that we have our test for this one object, let's add another object. Let's select our rolled PCG. Let's add another entry into the placeable items. And this entry will be our bench, for example, this time. And you can see that our for each loop is going again through all of the nodes, but now we have two nodes. So first for the lump pole and next for the bench, and it's placing it each 100 units away. So let's continue with fixing the other variables to be used in our placement of points. And we can test with these two objects that we already have connected. So let's go into our subgraph, and in a similar way that we created this mesh reroute node, let's do the others. For example, drag out of here, do a delete attribute. The attribute that we will use right now is interval. And again, choose the keep only selected values. And if you press the A key and choose the PCG graph that you're trying to debug, you can check if the values are propagated properly into the graph that you're debugging. So I can see now that I have a 0 value for our interval, and this will be very bad values because we'll be placing all the things on top of each other. We need a bigger interval, like for example in our default example here we had 100 units for each placeable objects. Let's start with something like this, or even 200. Let's go back into our simple item, and now let's go to the default values section. So the structure is all the type of variables that you want to have, and the default values are the values that they will be loaded if you don't enter any other value. So for the interval, let's place 200. Let's save this. And if we now go here and press A key again, and maybe we need to compile and save our blueprint. Let's check now. Okay, now into our level, we can properly see the 200 interval that we have for our interval. Now let's go back into the PCG graph. Let's do a named reroute. So add named reroute declaration. And let's rename this to interval. Let's continue with the others. So the next one, delete attribute again, keep only selected. The attribute that we are going to do now is the start offset. Let's add named reroute, start offset. These three booleans will be again just selecting the attribute, and this mesh transform and transform randomization will be a little bit more problematic because we'll need to do some calculations for them. But let's make the keep vertical, has mirror, and reverse mirror values. Let's copy these three nodes. Let's connect them and write the proper name. So keep vertical has mirror and reverse mirror. If you don't get any error, you have the proper selector written here. If you have some wrong name, you will not get any value if you debug here the attribute. So you can see now for the keep vertical and has mirror, if I debug here, I have a value of false, but here, because I have the wrong name for the reverse mirror, I added one number at the end, and that's why I don't have any value. If I remove this one number, now I properly getting this value into my subgraph. Now let's add named reroute for this as well. So let's start using these values before we start to calculate the transforms. So here into our spline sampler, if you open this node, you can see that we have the distance increment value, which we can use with our interval variable. So right click, type interval or the name that you used for your named reroute and connect it to the distance increment. And next, right click, start offset, and connect this to the start offset variable here. So right now, if I save my graph and go into the level, for example, I can control the placement of my WAMP posts with the interval of 500, let's say, and you can see this increases the gap between the objects, and the start offset of 500 or even 1000. This means that I have a gap in the beginning, and I can use this to offset. If I don't want the first pole to be at the beginning of my road, like currently, I can add a 100 unit gap, and you can see I have a gap from the beginning. So these two variables are working. Let's continue with the keep vertical, has mirror, and reverse mirror. So these are based on the premise that you can have on both sides of this spline this object, and if I want this WAMP post to be on the both sides of the road, let's go into the subgraph. Let's add here transform points, and for these transform points, let's for now, before we are doing the calculations, just do 100 units or even 500 units to the side. So right now I have these WAMP posts sitting 500 units away from my spline, and I want to have the same WAMP posts on the other side of the road. So how can we do this? Let's do a branch node after our sampler here. And if I have the option has mirror set, so let's right click here, has mirror, I'll connect this to the output to be boolean of this branch. This means that if this value is true, I will go onto the output B branch, otherwise I would go into the output A, which I will not connect anything to this. But into the output B, I'll have transform points, and these points will be transformed the other way around. So for now, I'll just enter -500 here, because the value of 500 is just a temporary value to show you the use of these variables here. Later we will do the calculations for the position and we'll change this value, but for now this will be okay. So after these transform points, let's do another branch. And this branch will connect to the reverse mirror variable. So if you want to reverse the mirror, we'll do a transform points and we'll rotate them 180 into the Z direction. If not, we'll just continue forward. We'll do another transform points here. Later you'll see what is this used for. But let's continue. We'll do another transform points here, which we'll use for the scale later. And after this, we'll spawn the static mesh. Let's disconnect right now and move the static mesh spawner at the end. Let's save this. And if we go back into the level, now if we select our blueprint for the PCG road, if we check the has mirror variable for the white poles, we want to see the poles on the other side. This clearly doesn't work for now, but let's check why. I have an error that the attribute mesh doesn't exist. So this is because for my mirror objects I'm not adding this attribute. So let's move this at the end. Let's connect this here, this output here. And now let's connect everything right here. So let's save this. And right now you can see if I check this has mirror variable, I'm placing the objects on the other side of the road as well. And if I check the reverse mirror, they're rotated the opposite side to the ones on the right. So these are pointing towards us and these are pointing away from us. This will allow us, when we can add the transform here into the variable, to make them both facing the inside of the road, because they need to be reversed on the opposite sides of the road. Let's continue. Now we are not using this keep vertical, and what this is doing, let's move this point here. You can see if we have a point higher than the other points, this means that we have a slope on the road here. We don't want our white poles to be perpendicular to the road. We want them always to be perpendicular to the world ground plane. So they always be facing upwards. Let's go back into our subgraph. And here, after these transform points that we'll use for the scale later, before adding the mesh attribute, we'll do another branch node. So do a branch. Let's use the keep vertical name tree route and connect it here. So if we are not doing a keep vertical option, we'll just continue as normal. And if we are, we then will do a transform points. These transform points will do a 0 rotation, but with absolute rotation checked. So we will rotate our objects with the 0 value for X, Y, and Z coordinates. And this will be in world coordinates. Then we'll copy an attribute. We'll copy the attribute from the rotation. Let's do a rotation yaw. This means the rotation of the object into the vertical direction. And the output target will be the source attribute. So we'll copy the rotation yaw again into the rotation yaw. but of the items that are not being rotated in the absolute direction. So this is the default rotation that we have. This bottom branch here is like you see our objects currently, and the top one is without any rotation applied at all. So we'll copy the value for the vertical rotation of this top branch into the regular rotation that we have at the bottom, and this will zero out the rotation into the vertical direction, and we can connect it to the at attribute node, and let's test it into our level. So if we select our blueprint again, let's mark the keep vertical, and you can see now, even though we have a slope into our road, so you can see that the road is clearly higher in the middle, we don't have added rotation vertically to our white poles. We can choose this by marking and unmarking this keep vertical checkbox. Again, the has mirror controls if we have the second object on the other side, and the reverse mirror if the object is rotated the same way or the opposite way to the original object. The transform of the mesh requires a bit of calculations. So let's go into our PCG subgraph. Let's start doing these calculations. I'll try to explain everything, but you can go back and rewatch it if something is not really clear. So let's go here where we are extracting all the variables from our structure. Let's do again a delete attribute. Let's keep only the selected attributes, and let's copy the name for the mesh transform and the transform random for the other attribute. Transform random. Okay, let's inspect and make sure it's working fine. So press the A key. You can see the values coming to both of the variables. So everything of the connection is working. Right now, we'll break these transforms. So let's first break the mesh transform. So right break transform attribute. We'll use the translation and do a subtract node. We'll break transform attribute again, and here we'll just name our three attributes. So add a name tree route, random position, random rotation, and random scale. We have these three values, and we'll use them in our calculations here. So first, let's subtract our random position divided by 2. Let's connect the random position to a divide node and then create attribute and create it with the value of 2. Let's connect this. So we'll use half of the random position and we'll subtract it from the original position, and then we'll use the other half and we'll add it to the original position. In this way, we'll get 2 values, which will be our minimum and maximum for the positions. So this will be at name tree route again and call it item position min, and then the max here, item position max. So these two positions will be connected to our graph here. So let's start with the position. Let's go back into our graph. So first we are sampling the spline with the interval and the offset. And then here where we are transforming our items with 500 units, let's connect actually the item position min and max. So right click, item position min and item position max, and connect this to the offset min and max values here. Offset min for the minimum and offset max for the maximum. And we need to do the same for the mirrored object. So here, instead of using -500, let's copy this position min and max. Let's multiply them by -1. So create attribute -1, because on the top one, for the example we used 500, and for the mirror we used -500. So we will multiply each of those values by -1, and we'll use these newly created values into the offset min and max. Let's save this and go into our level, test everything. So right now, if we choose our blueprint and we enter a mesh transform for our white poles of, for example, 500 units, you can see the regular white pole is the one on the right. Let's uncheck it has mirror. So this is the original white post. Has mirror is checked, and now I have a second one on the left, and I can control both with this value. They're not fixed to the 500 units that we had before. I can use this value. So the next thing we'll do is add the rotation values, calculate them and add them, and also the scale values. Now that you know how we connected the transform values, this should be easier. So for the rotation, let's go back here where we are breaking our transform for the mesh transform. We are getting the rotation here, and let's do a rotator combine. And the rotator that we need to use is the random rotation from our name tree routes here. So this random rotation. Let's move this a little bit down. So now let's get our random rotation. Let's do a rotator invert and connect it to this combine rotator. Let's copy the random rotation and the rotator combine here, and combine the rotation with the random rotation without the invert for the other value. So the top one with the invert will connect to a new name tree route, and we'll call this name tree route item rotation min, and the other one item rotation max. So now these two new values we can use into our graph here. Let's use the rotation for the original objects here, item rotation min and item rotation max. So these two values will connect here to the rotation min and rotation max values. And this is everything for this transform for our original points. For the mirror points here into our branch at the bottom, we'll do the rotation at the end, because we need to know if we are going to reverse the rotation or not. So here at the last transform that we added for the branch for the mirror points, we'll get the item rotation min and max, and we'll connect them to this transform rotation min and max at the end. If we are doing a reverse mirror, we'll go through this transform points, which is rotating them 180 degrees into the Z direction, and after this we'll apply the regular rotation, and this will do the reverse rotation for our objects. If we are not marking this reverse mirror, they'll just get the regular rotation without this transform points, because they will go through the output A branch here. And here at the end transform points we'll connect our scale values. So let's do the last values here. Let's move everything a little bit so we have a place for the scale calculation. Let's connect our scale to a subtract and to an add node. Similar to the position here, we'll divide by 2 the random scale and subtract it from the original value and add it to get the min and max. So get the random scale named reroute, divided by 2, connect it to the subtract and add named reroutes for the item scale min and item scale max. We'll use these two named reroutes at the last transform points here, before the keep vertical branch. So connect the scale min to the scale min transform point and scale max to the scale max value. Let's save everything. So here is how our final graph is looking. First we are getting the spline from our blueprint. We are sampling with the interval and the offset. Then for our regular piece here at the top branch, we are transforming it with the min and max rotation and translation. Then we are scaling it with the min and max values. Then we are deciding if we are keeping it vertical or not. At the end we add the mesh attribute, and we are using static mesh spawner to place with this attribute name of mesh the mesh that we have entered into our struct. If we have a mirror, we are going down here into this branch. We are again using the position and the rotation min and max, but we are multiplying the position by -1, and the rotation we are applying after we decide if we are going to rotate or not our objects in order to have the reverse effect of the mirror. So let's now go into the level and see how everything works. So I have this white pose. Let's look from a little bit more far away. So for the scale, you can see that I already have different scales, and this is because into our struct value here for the item simple, into the default values, our transform random has a value of 1 for the scale. So we are randomizing the value already. We are going to enter a default value of 0 for the scale randomization, and we'll leave the mesh transform default for the scale to 1. So all the objects will be 100% scale at the beginning, and we'll then add randomization if we want later with this transform random. So make sure the default values of the mesh transform scale is 1 and the transform random scale is 0. Let's save this. we need again to recompile and save our blueprint. So let's go into the level right now. Now I don't have the random scale anymore. And let's start entering the values. So I have a 300 units location placement for our white poles away from the line. This is working fine. Let's add rotation of 90 degrees in order to point to the middle. Let's make it a little bit more far away. And let's uncheck the reverse mirror. This makes it rotate the same way as the original. Reverse mirror is reversing it. So we have this working, our position working, has mirror working again if we want the second object or not, and keep vertical is working on our sloped road if we want the object to be pointing up or not. For example, our benches will not be pointing up, they will be following the terrain, but our one poles will be always pointing up with this keep vertical. And now let's test the random transform. So for the location, let's add, for example, a random location of 200. Let's add a little bit bigger number to be easier to see, and let's reduce actually this. So it's again easy to see. Let's actually put a 0 and remove this has mirror. So now you can see that if I don't have the randomization, everything is just on the spline, so where our benches are. But if we add a random location of, for example, 100, our objects start to be moved left or right. Let's do a 500. This will be maybe easier to see with the bench. Let's add a random value for the bench, for the location, for example, 100. Now you can easily see that the bench is randomly positioned along the spline. So our random value of the location is working. Let's keep it at 0 and test the rotation. So if we add rotation, random rotation in Z direction, it's working fine. Let's do a smaller one. So for example, 20, and you can see the rotation is working fine. And let's try the scale. For example, this will be easier with the white poles maybe. Let's check a random scale of 0.5. You can see now they have all different sizes. So everything into the placeable items works fine. We need to do the same for the spline mesh that we are going to use to create the actual curving part of the road, like you can see here, for example, at this example level. I have this road curving along the spline, so here we'll use the other struct and we'll use a similar subgraph that we created for the simple item, but for the curve item. So let's save everything. Let's create another subgraph by right-clicking, typing PCG graph. Let's call it PCG subgraph curved item. Let's save this, open the PCG road. Let's do the same like with our simple items, but let's do the loop for the curved items here. So drag into our PCG graph, create a loop node, the bottom option, connect this to the input. Let's change the getActor property name from placeable items to the other curved items into our blueprint. We'll use the other struct. Let's save this. Let's go into the curved items graph. Let's change this type to point. Let's save this. And let's go back into our level and let's delete these items for now. So delete both the placeable items and let's add some items into the curved items. So add one item, which will be this rolled. Let's save this and let's start working with this subgraph for the curved items. Let's do the most basic placement as at the beginning for test, like we did with the other subgraph. So get spline data, then do a spline sampler. The spline sampler will be of a distance type and the distance will be 680 because that is how long my rolled item that I connected is. We'll later again replace this with a calculated value. But after this, we'll do a create spline. We'll add the attribute, which will be our mesh object that we want to place. And we'll then do a spline mesh spawner. So spawn spline mesh. And here this add attribute will output again to the mesh attribute. We'll again do the same as we did before. We'll convert this point to attribute set. We'll delete attributes. We'll keep only the selected and the selected will be the mesh. Let's inspect this with clicking the A key and selecting this PCG graph here. We can see the value is properly generated here. We'll add a name tree route and call this mesh, and we'll use this name tree route here as an attribute to add. So this spline mesh, let's minimize everything, and here into the spline mesh override descriptor, we'll create an override. The input will get the mesh attribute and the property target will be the static mesh. And right now, if we go into the level, let's save everything, you can see our spline mesh is properly placed into our level and it's following the curve of our spline. So everything seems to work. Let's continue with the other attributes that we have into our struct. Let's see what we have into this struct item. So we have the position and the position offset, and as you know, this will require some calculations. So let's first start with the other values, which are easier. Has mirror, reverse mirror, forward axis, and up vector. Let's drag out of here, delete attributes, has mirror, delete attributes. Next one is reverse mirror. The up vector. And the forward axis. Let's do a name tree route for all of them. So here are all the values except the transforms, which will require some calculations. So let's check if everything has value by clicking the A key and selecting the subgraph here. So everything seems to work fine. So we have all the names properly selected. Let's continue with modifying this subgraph to use all of these values. So after we get the spline data, we are using this spline sampler, and we are having this distance increment currently set to 680 units. This needs to be changed to the actual size of our mesh. So if you watched the spline mesh video that I have linked into the description, you'll know how to do this, but let's redo it now. And if you want more details, for sure make sure to watch the video. We'll convert this from attribute set to point. Then we'll get bounce from mesh. We'll connect this attribute here. We'll do a subtract, and we'll subtract the bound max and bound min in the x direction. We'll then convert again from point to attribute set. I already have this node, so let's connect it right here. We'll delete the attribute and keep the interval, which we'll export from this subtract node here. So let's get the debug value here by clicking the A key of this on this subtract. Let's move it at the end, and you can see this interval is already calculated at 680. For our mesh, this is the proper size, so it seems to work fine. And now let's write here the interval value. So if we keep only the selected, you can see we have the interval value here, and we'll add name tree route for this interval. So now into this spline sampler, we can use this interval into the distance increment. This will make sure that our graph is working properly for each different type of mesh. It will calculate the size of the mesh, and it will sample the spline based on this size. Okay, so for our second mirror branch, let's drag out of here, create a branch node. Let's use this yes mirror, similar to the subgraph that we already did. We'll output from B and do a transform points. We'll use this later with our position and offset, but we'll create a spline here. And we'll do a select. We'll reverse the direction of our spline for the other input, and the select will decide based on the reverse mirror. So if we are reversed, we'll reverse the spline here into the input B, and we'll use the input B, and this will connect here into our add attribute value. So here we are deciding if we are having mirror, and here we are deciding if we are using the regular spline or the reversed spline if we have this reverse mirror value set. So let's get the forward vector and the up vector and the forward axis. Again, this is explained in details in the spline mesh tutorial that I have linked in the description. But we'll use a modulo operator here. We'll create attribute with a value of 3. And we'll use this result as our forward axis. And our up vector will use in this spline up direction. Let's save this. Let's go back into our level and let's try to see if everything is working. So in order to check this has mirror and reverse mirror, let's do a transform points here. Again, similar to the last subgraph that we created. We'll move this 500 units, the original piece, and after this we'll move minus 500 points the other piece. Okay. Ignore for now the look of this, but let's check if has mirror is working. Yeah, has mirror is placing another object on the other side. Reverse mirror is reversing it. You can see if I check it that the road is changing directions. It's a little bit hard to see right now, but let's maybe use this as an example. So if I check and uncheck the reverse mirror, you can see that the mesh is rotated the other way. The forward axis, I can use a value from 0 to 2. It is working. For this object it has to be 0, but for other type of objects it's going to be another value, but the important thing is that it's changing into the level, so this means it's working. And this subvector again is working fine. We need to have this subvector with the default value of 1 for the z-axis. That's why we had a problem with how it looks after we connected this. So you can see with the value of 0 we don't have really a vector set, but with the value of 1 it's properly oriented into the level, and we can see now the reverse mirror a little bit more easy. So let's go into our default values for the struct, and for the up vector let's add a default value of 1 for the z-axis. Let's save this, and now let's reconnect back this. Let's remove the mirror and the reverse mirror, and into our subgraph let's remove the 500 units translation, and let's try to use the variables that we created. So in order to calculate the position and the offset, it's a little bit more easy than we had for the other type of objects, because we are only controlling the position right now. We don't have the scale and the rotation. Let's again use the delete attribute. The attribute that we want is the mesh position, and the other one is the position offset. So let's do the mesh position. Let's copy this and do the position offset. Let's copy. And the mesh position we can use it directly. So drag out of here, add named reroute, or let's do it the same as the other graph to be consistent. So let's do a subtract and add note. And the thing that we'll subtract and add is half of this random position. Let's divide this. Let's create an attribute. This attribute would be a value of 2. So we'll divide the random position by 2, and we'll subtract it and add it to the regular position, and this will create the item position min and the item position max. Okay, let's use these values back into our graph. Here where we added the value of 500 before for the demo, let's use the item position min and item position max. Let's connect them to the offset min and max. And back down here for our mirror, let's use again our item position min and max, but we need to multiply them in order to change the position. And I'll multiply them by a vector. And this vector will have a value of 1, -1, and 1. And this will reverse only the y direction. So this will make sure that our position into the z-axis, for example, is the same, but we are reversing the position into the y-axis. Let's save this. And now let's go back into the level and check. Right now I can control the position of this rod, or actually let's add another item. So we test with multiple items. Let's use this. Let's have an up vector of 1. Let's move it 500 units. Actually minus 400 units, because we want this side to be facing the road. Minus 300, minus 350. Okay, minus 350 seems fine. Now let's check the has mirror, and this mirror we need to reverse it. So we want the other direction to face the inside. So this seems fine now. And let's check the position offset, for example, into the y direction. Let's have a 100 units offset. So you can see the offset is working fine. The reversing works fine. The forward axis and the up vector we can test with another mesh. For example, here, if I place this road mesh and this mesh, you can see that the direction of the road is facing a different axis. So this road is facing the red arrow, which is the x-axis, and this road is facing the green arrow, which is the y-axis. So if I replace the road here, you can see they're placed sideways. This is because our forward axis is set to 0, which is the x-axis. If I set it to 1, which is the y-axis, and then I need to fix the up vector as well. Like this. So you can see our forward axis and up vector are working again. Let's do a minus 200. Right now, you can see we can use as many objects as we want into our spline mesh type. Let's make sure to recompile and save our blueprint, because the default value of the up vector is still not coming. Right now this should be fine, and we can reposition the mesh. And have mirror and reverse the mirror. So this allows you to create roads or other curved objects and place another objects next to them. For example, let's place the benches right now. and you can control the placement of all the items and the way that they are placed and rotated alongside your road. And you can see this creates a very robust tool to place your objects into the level and create everything as a very easily editable spline, which you can modify very easily by just moving the control points. Let's hope this helps you first to understand how to create PCG tools for your level creation, and then specifically how to use this road generator. If you have some questions, write in the comments. If you liked this tutorial, please like and subscribe for the channel. If you want to support me, you can join the channel. This will also allow you to watch the videos earlier. And guys, I'll see you in the next tutorial. Bye!